the node numbering. Even the area of the member is given. Okay. So if you are going to count, we have four member. Okay. Now this is a trust. Okay. The support system are what we call all pin, no pin, because it cannot be A or D cannot be a roller, or else it will be unstable. Okay. To make it stable, A and D must be pin. Okay. Now, aside from the thrust, there is also a 40 kilonewton. This is what we call real load. Real load. So, uh, there's a 40 kilonewton subjected at C. Okay. Then, as a result, the thrust will be deformed. No? Will deform. So, some of the members here are tension. Some of the members here have zero load. No, zero load. So those and some members have compression. Okay, so those load that has tensile force will be there will be lengthening. There will be an extension or what they call that a change of length, positive change of length, meaning there is lengthening happen. Why? Because of the tensile force. Okay, so just like if you apply a tensile force to a rubber band, so there is a change in length. Okay, and that change in length is what they call delta. No, all of this have change in length depending on what forces they are. Now, if the particular member here is under compression, the change in length will be negative, meaning it shrink a little. It will there's a shortening of the length of the member, but that shortening will depend on how sturdy or how rigid the material or the member is. No, if the member is made up of weak material, it could deform easily. If the member is made up of strong material, sturdy material, hard material, or what we call rigid material, then uh, the elongation is very small, no, with respect to the load. Okay, so those member which has zero load has zero deformation. Why? Because deformation is dependent on the load. Okay, so that's it. So this is what happened, and then there's a 40 kilonewton load. Before I will discuss to you what will happen to this class when there is 40 kilonewton load. Let us first discuss how many members are there, and we should name them according to the nodes. So we have AB, that member is 4 meters, so I put 4 meters here in the second column, and BC, I have, okay. We have member BC, okay. This is 3 meters, so I put 3 meters here in the second column. Okay, I will make this one. Ako lang siya kung anong i-bold para gwapo. Mamayo tanawon. Sila lang term na gwapo kay para mang gwapo sa tao. Pero, okay. So, para nindot tanawon. Okay. EC is from here to here. No, this is 5 meters. So why it has 5 meters? Because this is 3 meters, 4 meters. So the hypotenuse is 5 meters. So I put 5. And then lastly, CD. This is 4. Okay. Actually, you can sum up how many, how long, how the total length of the material, but for the time being of determining the delta actually is not really very necessary. No? You need to sum the product lang. So whatever your answer here, this one will be the answer, no, of delta. Okay. But before we go that, we fill up the third column because it appears here in the equation. In fact, it's a denominator here. So for AB, that is 1 to 50, 1 to 50. Let us say that the area is in mm squared. Ano ba tawag mm squared? Pag ginasin mo sa first grade. Well, this one is Himuon na lang nato ng mm para consistent as unit. So this will be 4,000, 3,000. Mutana mo, dagwa po sa imong mga lead, sir. Of course, mm mo na, no? Do you know how long is 1 mm? Kamay ka ng 1 mm, oy, mga taas sa umigas, no? Umigas. Umigas gani. Is mabot pa ng 2 mm yung taas. It-il na sa umigas, no? How about BC? That is 625. Okay. And AC 625 gihapon. 625. And DC is 1 to 50. How about the modulus of elasticity? We will use megapascal, no? We will use megapascal. We will use gigapascal. So if that is gigapascal, that is 1,000 megapascal. GPE, no? So if you remember that 1 megapascal is equal to 1 Newton per mm squared. So I write mm squared this way, not a fractional, but you can write it in this manner, to the negative 2. If you don't want the negative 2, then you just use the divide in squared. So that's how it's right. This one is megapascal. That is megapascal. How about 1 gigapascal? So 1 gigapascal is just 1,000 over megapascal. So that's good. 1,000 14 to the cube of Newton per mm squared. Okay, that's not 103, ha? That's 10 to the cube. Okay, to the cube. Okay, now E is 210,000 megapascal for all because these are made of steel. No, E, B, B, C, AC, and DC are made up of steel. So therefore, I will put here 210. The unit is gigapascal or kilonewton per mm squared. This one is 210 also. 210 also. Kung sa nag-ingon niya, kahoy ang isa ani. Para magamit na og different A. So, it's made up of the same material all over. Okay, the four column can be determined directly, no? If the given are there, no? But the in, we can use our theory of structure here, no? Like method of joints. Okay. So first is we are going to determine the reaction, no? The reaction. Okay. So we will analyze actually, no? We will analyze this, no? We will analyze this. So ang mahitabuan niya is naani siya reaction, no? Naani siya reaction. Okay, ato ba tayo reaction? Reaction. Shape. Saan ka nag-reaction? Okay, muna siya ang reaction niya isa. Ito lang siya format ng takuon. Takuon tala siya. Format of. And then what happened? Ang color ato i-change into black. Dakuon na ito siya. Ano ito siya? 3. Okay. That's the reaction at A. The vertical reaction at A. I'm going to copy that. Copy and paste again. 1, 2. So one of these is the reaction here. Okay. And then one of that is a reaction here. Okay. That's directed towards the pin. Okay. So that's how it is. Now, YD has no horizontal reaction. Pin man na siya. Of course, mao gyud ang mahitabo kay nga naman bar man kuno siya, no? So ang bar is a straight gyud na iyang load na diha, no? Lagi ni siya compression load kay kung imagine nimo maputol na siya, ang mahitabo na maputol na siya, ako doing ha. Usay mahitabo kung maputol ng DC. Okay. Insert shape. Ating ito gamiton. Okay. Mauni siya ang line BC. Ako na siya takuod. Okay. Yan ang color ako i-change into red. And then the line is niya ang gamiton. Okay. Mauna siya. Okay. Ang color din yung ma-change. Okay, muna siya ang line C. Kaya kung kopyahon ko na siya, if I'm going to copy that, copy and paste. This will be also the member BC. Okay, that's the member BC. Okay. Muna siya member BC. And paste again. I have a member. This is member BC. So, isa rin na easy dito. Yeah. Okay. And then paste again. Paste. So, I have my member. Okay. Now, atungutan ang sa may tabo kung na 40 kilonewton load. So, depending on what kind of console, but I already imagine what will it become. So, joint C will move somewhere here. Okay. And so, this will be the exaggerated depicted structure. Okay. So, that is what happened. No? So, the most important member here so that it will not collapse is CD, no? CD. So, kung maputol ang CD, the whole structure will collapse, no? If CD will break or will give way or will buckle, no? The whole structure, even though this is in a triangle, okay, okay. So, CD should have a compressive load. Okay, should have a compressive load. Okay. Now, C will move to C prime, and then that is the object of that is the problem here. Determine the horizontal displacement delta C. But before we go that, we still answer what is N. Okay, N. N is actually the axial force, internal axial force due to real loads, and the real load is 40. No. So again, I am going to solve this. No, I'm going to solve this. Okay. I will put it here. I will redraw again. I will redraw. Okay. I will change that into this. Okay. And then copy that. Copy, paste. So I have also another one here. And then paste again. This is another member. Paste again. This is the fourth member. Then maybe I'm going to join all of them. I will group it. Group. Then this one also. The third. The fourth. Then group. So that if I'm going to drag it, there is still one. Okay, that's good. Okay. That's all. I am already here. Put that here. Okay, I will put this C, and then there's 40 here. 40. This is E. This is E. And this is B. Then aside from that, there is this load there. There's a load there. This is 40 kilonewton. Okay, that's 40 kilonewton. We move this nowhere. There. So, okay, that's 40 kilonewton. Aside from that, there is also a load here. Copy that. Copy. Okay. Paste. Okay. So we call that reaction. Actually, we remove that up a little. Another space. Okay. So I will copy this. Home, copy, paste again, paste again. So one is here, and one is there. Okay, all. Okay, that's the reaction. Okay, that's the reaction. Okay, so I want to determine the reaction. Just like if I will see that this is AX. So ang hitabo na rin sa silong, tago na ko ni siya o dy. And the other one is dy. Okay, dy. Okay, submission forces. So consider whole structure as free body diagram. Okay, so you want to make this in equilibrium. So the first thing I will do is submission forces X is equal to 0. Then I will do submission of moment at A equal to 0 to solve the other one. And then I'll do submission of forces Y equals to 0. Okay? And then I will change this into its Greek sign, Greek symbol. So it will become sigma. And then this one is also a sigma. And this one is also a sigma. Sigma. And then I want to make this big. Maybe 16 will do. Okay. So if consider the whole body here, you have a structure here. This is the model. And then you have a 40 kilonewton real load. Because we are trying to fill up the 1, 2, 3, 4, the fifth column. The fifth column is the axial force of 4 members due to the real load. But we can only determine the real load if we know the external reaction. So determining the reaction, determine the reactions AX, DY, and DY. Okay. So we do submission of forces X first. Maybe I am going to put that in a box. No, I will insert a box. So I will use this. Okay, I will use that. First, I'm going to cut this one and put it here. Cut that one and put it here. Cut that one, put it here. Okay, so the first equation actually of submission forces X is I will have EX. Hindi na siya symbol ba area. Okay. EX my plus 40 equals to 0. So EX there is equals to negative 40. Yeah. Okay, do not worry about the negative. That means the 40 kilonewton is okay, no? But the negative means that the sign of the assumed direction here. So if the assumed direction there is going to the right, that means that you have negative 40. That means in actual, the reaction is directed to the left. Yeah. Okay. So that is what we mean by AX equals to negative 40. That is supposed to be a subscript. Subscript. This is a subscript. Okay. So we have solved already this one. It's negative 40. So we will put here equals to minus 40. En. Okay. So for EY. Okay. Solving for EY, dy, we sum up moment at A. No, at A. So if we do that, so if we put our finger on A, we notice that A, EY, and EX are useless, no? They have no moments about A. So there are only two forces which rotate about A. The dy with a moment arm of 3 meters and the 40 with a moment arm of 4. Now we use the sign positive CCW. Okay, positive CCW means positive counterclockwise. Okay, if positive counterclockwise, so 40 rotates in a clockwise manner, so it's not counter. So that's multiplied by 4. Okay, I think this is to be area yeah, 40. Then dy, however, dy, okay, dy is rotating in a counterclockwise manner with a moment arm of 3 meters. And then since there's none, so it is split into 0. Okay, we put y as a subscript.
Sir, pwede
Okay.
mag-question,
So
sir?
from this, huh?
Pwede, ano yung question, sir?
Yes, question. Okay.
Sir, ano ganito,
Wait.
kung na, wala ko kagets, kato bitong if pin ang D, anong walay horizontal nga reaction, sir?
Okay. If there is a horizontal reaction, that means that ang iyang ana, resultant ana niya is inclined. So if the reaction here is inclined, so dili na siya kuan. Dili na kung doon na siya yung horizontal component, if you sum up forces, if you isolate the like free body diagram of joint D, kung doon na siya horizontal reaction, yawa siya horizontal forces, this equilibrium is not attained. So in order that there will be equilibrium on joint D, dx should be 0. Okay?
Okay.
Dx should be 0.
Okay, sir.
Pwede mo utangan mo reaction actually, utangan mo dia. Actually, okay, kanang reaction. If this one has a value, then you isolate that one. So wala may lain force. So may force ang member, no? Member is axial force man gid siya. Okay? An axial force here is vertical. It could be going away or going in. Now,
Okay.
this member could only be in equilibrium if this arrow does not exist. This horizontal arrow does not exist. Okay?
Okay, sir.
So that it will not exist, we will as well as cut that. Okay.
Okay, sir.
Another is that you notice that this is not a triangle. The only triangle here is ABC, while ECD is not a triangle. Okay, that
Okay,
is a
sir.
violation of atras because they say that atras is composed of triangle. Now, because that is not a triangle, pwede gihapon basta ipin lang mo na siya para dili siya doon na siya parang imaginary na member diha, no? Parang na siya imaginary. So does not exist. That imaginary member is provided by the restraint of the reaction. Mura na siya doon na imaginary diha because pin man, pin. Okay? So but in kuan wala gina siya, no?
Okay, sir. Salamat, sir.
Okay. So got it. So here we can solve for dy. dy is equal to, well, 160 divided by 3. That's kilonewton, no? Positive dy. Meaning that dy is equal to 160 divided by 3 kilonewton. Okay? So, that's it. Now, if we sum up forces y equals to 0, we have EY, that kind of symbol, EY, yan, EY, plus DY is equal to 0. Okay, load line, no? But you know EY na diya, no? You know DY na diya, no? As 1. So that means that EY is equal to minus 160 divided by 3 kilonewton because ang DY positive man. Okay? Nanong negative man atong imaginon, ha? Kung wala pa ni gipunggan diha sa metawo, matuwang ni siya, mo-overturn ni siya, mo-tumbling, di ba? Mo-tumbling. So, ang purpose sa EY diha is nag-hold down na siya, nagpugong na siya para dili siya maalsa, no? Kung pananditan wala kayo ni siya na screw, ang mitabuan na niya mualsa na siya, no? So there should be a downward force for EY. That's why it's negative. The magnitude is 160 divided by 3, but why is it negative? You know, because initially we assume it positive, but it should be down. Similarly to AX. So this one is according to the assumed direction there is negative 160 divided by 3. Okay, well, this one is positive. Okay, we have not yet determined the internal forces, but I know if I'm going to sum up. Okay, ini lang kung ano. Ini ako. Okay, so okay, so ang tawag man gud nila sa kuan. Okay, so panita din ni. Siguro magbuhat ko og member na kuan na lang. So determine axial forces on member class o member class na lang o members they are what we call tawag na to N. They will occupy the N because in sa Castigliano's theorem ang N define na siya as the internal axial forces, no? Meaning the axial force, the member axial forces here. No, there are 4, no? So we need to put this here, okay? So we need to calculate that. So say using method of joint, using method of joints. So this is what will happen. I will create tawag ni insert patubok ng maton 1, 2, 3, 4. Okay, so here it be the joint. I think easiest is una sa D, no? Easiest ka ng D. Okay, so what happens kung nakakain mo na sa D? So ang ikabuan na niya is ako na siyang i-paste. Okay, muna siyang D, no? So, dinhi, doon na tayo reaction, copy, paste, copy. Okay, that is the reaction. We solved that already. And the second is, we represent this as D, no? So, we call that as this member, DC or CD because CD atong pagtawag na din na, no? CD and then I will say PCD NCD na lang instead of one. I will just call NCD, no? With the subscript. Okay, and this one is this is plus 160 divided by 3 PN. So therefore, if we sum up forces y equals to 0, this is what happened. Okay, so nang taungon. Okay, follow lang mga question lang mo kung naamoy question. Okay, we have in CD plus 160 60.3 160 divided by 3 is equal to 0. You have pin CD equals to negative 160 divided by 3 kilonewton. Okay, after this is subscript, subscript, subscript. So that means 160.3. So we will use a kilonewton here, no? And so, basig tingala mo N niya, kilonewton ha. The inside the parenthesis is the unit. Ini siya, ito na lang ni siyang ibuabo ni mo, ito na yung kilonewton per inch squared. Kilonewton per inch squared because that is gigapascal also. Okay. Okay. So CD, we have negative 163 divided by 3. Okay. So tulo na lang. Now, if we go to joint C, anita sa joint A na lang, joint A. So this is what happened to joint A. Joint A, joint A, joint A, it BB, joint A. So ini tabo, muna ni siya. Okay, that's joint A. Did a reaction here. Home, copy, paste. And siya reaction diha. And then we have also copy that one. Na siya reaction diha. Okay, nabawa na ng reaction. Then paste. That's the axial force. All going away, we assume din to positive. Okay, ini siya, muna siya ang pin AB. Ini siya pin EC. Ano ba yung EC? EC na ba EC? Yeah, pin AB and EC. Okay, so I will make that a subscript. I will make this as a subscript. Okay, while this one is doon na siya negative 40 diha, BN. Yan, yung isa. Okay. Okay. So, ako siya negative 40 BN. So, siya ako ibalik yan. Balik po. Okay, that's negative 40, while here is minus 160 divided by 30 in the upper. Okay, if we sum up forces x equals to 0, x, we will have in EC cosine of theta, in EC cosine of G, okay, then we have minus 40 is equal to 0. Ayaw lang ni, Q this, kung hindi Q kay theta, malakong sabot. Okay, that's Q, and then I symbol theta, and then this is a subscript, okay. But we know that cosine of theta, here we will define first. Cos of Q is equal to 0.6, while sine of Q is equal to 0.8. Okay, so this one is symbol. Okay, so we have here 0.6 in DC is equal to 40. So in AC is equal to, what is 40 divided by 0.6? So 40 divided by 26. That is 40 times 5 divided by 3. 40 times 5. That's equals to, in AC is equals to positive 40 times, that's 200 divided by 3 kilonewton. So that's the same, no? Because 0.6 is 3 over 5. So 5 is denominator. So it will be, sa palinusika, so mo na siyang 1, 5 times 40 then 3. So that becomes easy. And we just make this subscript and a subscript. Okay? So basically we know in AC as 200 divided by 3, this one. So that's positive 200 divided by 3. Okay, dili na mo butang positive. Next, if we sum up forces y, okay, sum up forces y equals to 0. Okay, there. Sum up forces y equals to 0. We will have in EB plus in AC sine of Q minus 160 divided by 3 is equal to 0. Okay, so we have this one symbol and this one subscript, this one subscript. Okay, then we can solve for in ED. Okay, so for in ED, and that is equal to the 160 divided by 3 is transposed to the other side, 160 over 3, then minus in AC, that will become 200 divided by 3 times sine of theta, which is 4 over 5. So we have 160 times 5 minus 200 times 4. In EB is 0. Is 0. So, how come? 0. Dapat wag isa load kayo, may load ang joint B. No? Kung naani siya load, that means na, madili mo ma-explain yan nung na-load siya. Nga may load ang B. Okay? So, that's it. So, in AB is 0. You know, if you have some 0, dali na tayo. Kay anything multiplied by 0, 0 mo sa siya. Buta na ito 0 daan. No? Then, ang BC na lang atong problema. No? BC. Okay? So, if BD joint B, sa kayo nagtabo sa joint B, no? Okay, joint B. Joint B is, yung ano siya. Okay. Okay, that's it, no? Joint B. Now, naka-force din copy, paste, 0, 0 man. Okay? Naka-force diha, copy, paste. And we call that as, tawag ko na ito na siya o PBC. Okay, PBC. Ito na ito PBC. Yan, din tawag ko na ito na siya o PBB. 0, 0. Okay, PB equals 0. So that's it. So if we sum up forces X here, copy, summation forces X, supposedly N data siya, no? Cannot just P. And then this one is NAB. And so, NBC is equal to 0. May lain, 0. 0. So, wala may load. Wala na, wala may memo. So, 0 din siya. So, mo, nalanin mo na subscript. Okay. Okay, that's it. So, you have 0. Here. So, anything, multiply mo diha. performing here with zero. Okay, so basically, duha gid ka member ang medyo kuan ani kanang relevant, no? Whatever bisan ko tawon pa ni 1 million diha, 1 million diha, the product of N and D in DP is still be zero. So it's useless to put in there. Okay. Okay, the next thing is this is tricky, no? So here you are going to determine the N, determine the you determine the N. The N are just the internal forces of the thrust due to the real load. Now, unsa ba din yung DNDP? Okay, this is the DNDP. Okay, according sa kondito, the DNDP, DNDP is the derivative of member forces if the load is P. Okay, if the load is P. Okay. Now, kining P, kung kuan, ako ning kopyahon. Okay. Dili na siya real load, no? Kung dili, i-apply lang na siya just because kuan, makuha usoy mo kaon ng DNDP, no? So may tabo na kay structure din eh. Asa ba ito akong structure? Wala mo siya ito na kopya. Wala lagi. Okay, home, copy, paste. Okay, I have it here, no? So, dalon. Okay. Okay. So, because you are interested on determining the problem is really is to determine the horizontal displacement of joint C, you want to know that. What you will do is you apply P horizontally at C. No? So, at C, here, at C, at C, at C. So, you apply a horizontal force here at P. Ganong horizontal mo sa di mong i-apply, di man vertical. Okay? Ang katarungan is that you only need okay, this is B, that's B, that's C, and here you have P, no? That's P. Okay, and this one is A, this is E, and this is B. Okay. So, EB and BC, doon na siya pero as I have told you, we will not waste our time on BC and EB. Why? Because even though dagdag ako na siya force din DP niya, but we do not need them because the product is already zero here. The product here is zero. So we need only EC and CD. Okay. Now, if that is the case, we can actually make a free body diagram of joint C here. No? Free body diagram pa sa joint C. So that will happen. No? Free body sa joint C. So may tabo ni mo sa joint C is mauni. Sa joint C, if BD joint C. Okay. If BD joint C is mauni may tabo. Okay. Mauni siya may tabo. Copy. If BD joint C. If BD joint C. So this is it. Okay, joint C. So doon na kay force din home, copy paste. Okay, na kay P. Yan, na dahil kay load din it's leave. Just go away from the node. Ini, hindi na ito na siya. So, kinahanglan na. Okay, na po dahil kay lain niya. Okay. Okay, na kay lain load din Okay. So, this is we just call this as if this is P, if that is P, this is what we call F, or yeah, N magyapon ko small letter N EC, and then this one is small letter N B CD. Okay, so I make that as a subscript. So summation forces x equals to 0. We will have 3 tip in EC, that's negative, minus 3 tip in EC, plus 4 plus P is equal to 0. Then we have in EC equals to positive 5P divided by 3. So 5P divided by 3, that's in EC. Okay, you have in EC there. In EC. Oops. Okay. Subscript no ulit naman. Okay, you have in EC there. Okay, in EC entered. So the derivative of that, d in dp is equals to positive 5 divided by 3. So that's d in EC, 5 over 3 here. That is 5 over 3, 5 divided by 3, positive. So the other one is when we sum up forces, is if we sum up forces y, okay, copy, paste, copy, paste, summation forces y, we can have 4/5 minus 4/5 in EC, then we have plus minus in CD equals to 0. So that is a subscript. Then we have in CD, in CD, we have in CD, in CD is equal to negative, no? Negative siya. Negative 4/5 of NEC. NEC is 4/5. 4/5 of 5 over 3. So equals to 4/3, no? Negative 4 divided by 3. So that's in CD. And derivative of that is you have dn dt is equals to negative 4 divided by 3. So we have negative 4/3 here. Negative 4 divided by 3. 4 divided by 3. Okay, 4 divided by 3. Now, if we are going to sum all of this, I have my calculator here. So we have n times dn dp. So we have n 200 times 5. Okay, 200 times 5 divided by 9, because that's root 3. Then multiplied by L, which is 5,000 times 5,000 divided by area, which is 1250, divided by elasticity, which is 210. So we have 2.116 mm. Okay, this will be in mm. Okay, the resulting unit would be if you have no? Then this one is minus. That's 160 times 4 times 4,000 divided by 9 divided by 1 to 50 divided by 210. We have 1.08 3, no? mm. So again, I will review 200 times 5 times 5,000 divided by 9 divided by 625 divided by 210. So this is actually 4 din siya. 4.233 mm. Then minus 4.233 minus 1.083, 4.233 minus 1.083. We have 3.15 mm. The sum will be 3.15 mm. So that is the deflection here. No? That is the deflection here from C to that. That's equal to 3.15 mm. Okay. So okay, I think it's time already, class. No. So but I have finished this one. Okay. I will stop sharing. So this afternoon, I solved problem in detection of gases in a classic way using the what we call this Castigliano's theorem. No? Ang sayon ani class is using computer, but in your board exam you are not allowed to use computer. So we will always deal with classic theories. No? That's the Castigliano's second theorem. Castigliano's theorem is very important in theory of structure. No? So, muna siya. So, this afternoon, I have solved a problem in deformation of gas using Castigliano's theorem. Okay? So, mauto siya ang buti ipasabot sa derivative sa n with respect to p is you apply a p sa area nga dito nyo pangitaon ang sa point nga din mangita ka og deformation. Unya, ayan direction, ang direction na po because the question is horizontal man, horizontal sa dagko sa p. Okay? O na siya. So that's all class, no? That's all.